kind of finishing up section 6 of Unit 10. And we're talking specifically now about, we have one theorem today, which is segments of secants and of tangents. So in short, without having to read this, I think I could do a good job explaining it. We have two things going on here. We have a tangent and a secant that share an endpoint on the outside of our circle. So they share the endpoint E. We could write EA if we want to do some labeling. EA is a tangent because it touches the circle at one point here and goes off. And then ED, E all the way to D, that would be a secant. And then EC specifically, we would call a secant segment. If you want to be super specific, you can call it an external secant segment, but we'll just say secant segment. So EC is a secant seg. Seg for a segment. And what this formula is saying, we're going to put this formula and use these labels that we just made so we can have it in kind of in words and also in letters. So we could write this as EA squared. EA is our tangent, so we could write this as it is our tangent squared. Equal to our secant segment multiplied by the length of our secant. Say secant seg. That's not the notes we're on. Where'd geometry go? All right. Secant segment times the length of our full secant. So now you have a bunch of different ways to look at it. You have it in words, you have it in symbols, and that makes it easy because once you identify what is what in your diagram, you can go through and just plug things in. And when you have a lot of formulas, it's nice because plugging in makes it a lot simpler. And again, we're just using these same basic vocabulary words that we learned at the beginning of the chapter. So looking at our first example, we're trying to find WX. If we label our pieces, WX is our tangent. Why it's a tangent? Because it touches at one point. The segment XY, which has a length of 12, that's our secant segment. I'm just abbreviate SEC, SEC, SEG. And then the length of our whole thing, X to Z, that's just our secant. So you can use our formula that we put in writing or use the symbols to fill in what we're trying to find. We would have to square our tangent. Our tangent is what we're trying to find. It just has a length of x. So we're going to square x, x squared. And that is set equal to our secant segment, which has a length of 12, times the length of our full secant. And to find the length, we have to add these two together. We have to add 15 and 12 together. So this has a full distance or full length of 27. So that's what we'll multiply 12 by. We'll take 12 times 27. Twelve times 27 is 324. So we'd say x squared is equal to 324. And then kind of going back to an algebra step, to undo the opposite of a square is taking the square root of something. So to get an x, there's one x on our left-hand side. We'd have to take the square root of both sides. So we just have then that we have one x, or x to the first, left on this side. And you do this on your calculator, square root of 324. 324 is a perfect square, so you get out a whole number. We'll get out 18. So 18 times 18 is 324. So that is our length of our tangent, 18. Wx is equal to 18. So this is kind of a good basic level problem where all we have to do at the end is just take a square root. The next problem is going to be a lot more involved because we're going to end up putting in a quadratic and then having to use quadratic formula. But we'll talk about that when we get there. So RS, we're trying to find. So from here to here, if you don't want to write out what is what, you could just label it above. You could say that right here, this is our tangent. RS is our secant segment. Then R to T is the full secant. So we take our tangent squared. So we got to do 16 squared. I'm just going to write that as is. I'm not going to square it yet. 16 squared is equal to the length of your secant segment, which is x, times the length of RT, which is our secant. So we know part of it is 8. The other part of it is x. So we can go back from Unit 1, use our segment addition postulate. The whole length of this would be x plus 8. Whenever you have a variable in front of a parentheses or anything in front of parentheses with multiplication, you should distribute, and that'll help our simplification process. So boom and boom. If we can square 16 while we're at it, so taking 16 times 16, which is 256. So 256 on our left-hand side. X times x is x squared. And then x times 8 is 8x. So plus 8x. All right. This is where things kind of get down deep into the weeds, where you have to go back to algebra to be able to solve this. We have an x squared and an x term, but we're kind of missing our constant in the back for a quadratic. So to be able to factor or use quadratic formula, we have to set one side equal to 0. So I have to subtract 256 from both sides to start. So if you have something like this, set it equal to 0. So I'll put note on the side. We're doing this because we can set, write in a smaller pen size so it doesn't, set equal to 0. So that we have to subtract 256. So then we would have 0 is equal to x squared plus 8x minus 256. Now we have a quadratic. We have x squared plus 8x minus 256. That's what a quadratic is when it has an x squared term to start. And whenever you have something like this, we kind of dealt with this a little bit last week, you kind of have two options. You can either try factoring this, and if it's not factorable, you have to use quadratic formula. So I'll put kind of in your instructions again off to the side. You factor, or you use your quadratic formula. Factoring is a quicker way where you would try to find two numbers that would multiply to negative 256 but add to 8. So setting up kind of your factoring steps, you would set up your magic X. And then you try to fill in your two numbers on the side, which in this case you cannot. This is a quadratic that is unfactorable. So you have to use your second option, which is quadratic formula. So using quadratic formula, we do it off to the side. This will be another algebra review. So quadratic formula. This is a big kind of staple of Algebra 1, where the formula is your x values are equal to your negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So when we plug in values for a, b, and c, we're going to have two answers for x in the end from this plus and minus. And how you get your a, b, and c values are from this quadratic we set up here. Right? We call this a standard form of a quadratic, where it is 0 is equal to ax squared plus bx plus c. So kind of each number in blue is kind of a placeholder for a, b, and c. So there is a 1 really in front of this x squared. So our a value is 1, our b value is 8, and our c value is negative 256. So once we have those three things, we can plug them in, and then it's just like order of operations all the way through till you get your two answers for x. So we would say x is equal to our negative b value. So our b value is 8, so it'll be a negative 8. Negative 8 plus or minus, and I'm going to show everything. So b squared, so that'll be 8 squared, minus 4, and then it's times a and c. So I'm going to put a and c in parentheses. A is 1. C is negative 256. And this is all divided by 2 times a, which is 1. 2 times 1. And from here, using order of operations, anything that's underneath the square root symbol, we have to simplify first before we could do anything else. So we take 8 squared and multiply these three terms together. I gotta plug this in, apparently. Isn't charging. Alright. So this would be, like I said, 8 squared is 64. So we would write this as x is equal to negative 8 plus or minus square root 8 times 8 is 64. And if we take 4 times 1 times negative 256, that's negative minus negative 1024 divided by 2 times 1 is 2. All right, we're going to keep simplifying what's underneath here till we get it to one number, so we can take the square root of that number. So 64 minus negative 1,024 will give us 10,088. Sorry, 1,088, not 10,000. Add an extra 0. So I'll do it up here. We have x is equal to negative 8 plus or minus the square root of, we simplified down to one number, 1,088 over 2. Right. Now we can, since our square root is just one number, we can take the square root of 1,088, which we'll get, it's about 32 point, let's round it to 2 decimal places, so we'll say 32.98. Say x is equal to negative 8 plus or minus 32.98 divided by 2. All right, we're in the end game now, where we have to use this plus or minus here to get two different answers for x. Whenever you see a plus and a minus like that, that means do it one time with addition, the other time with subtraction. So I like to draw two little branching arrows to show I'm doing each one separately. So I'll do negative 8 plus 32.98 divided by 2. And then negative 8 minus 32.98 divided by 2. And when we're doing this, you have to make sure that you get your top number, your numerator, to one number before you divide by 2. So don't divide each by 2. That's more work than you have to do. So we take negative 8 plus 32.98 and split it in half, so divide by 2. One of our answers, x, could be 12.49. The other one, we take negative 8 minus 32.98, then split it in half. We get x is equal to negative 20.49. So we have two answers, and the question is, well, which one do we choose? If you go back to when we started this problem, we're looking for a length. All right, we have two options of x could be. X could be a positive 12 or a negative 20. When we're talking about length, we can't have a negative number. So in the context of geometry, this answer is, we would say it's not valid or it's out of context. So our answer is the positive value. So I was going to be here, if you always get two x values in geometry, your answer will always be the positive one, because we're usually talking about a length of something. So big picture, the formula is the easy part. Going through this is the tough part. What's in orange here, you're not going to be, on the test, you don't have to go through and use quadratic formula. However, on the homework, you may have to do it, I think you have to do it once. Other ones you can just fact. The homework problem, the test problems will look more like the first one when you get to that point next Friday. If quadratic formula is still rough on it, or maybe your algebra teacher just said, I'm going to bypass quadratic formula altogether, you and I can sit down and talk about it. It's plug in numbers and just order of operations, so it wouldn't take too long. Two examples on the back side we could talk about quick. We won't go through them in their entirety. We're now trying to find the radius of this circle here. So finding r or r. Both these r's are the same. You can't have two different radii in the same circle. So you could simplify this piece here. So I think there's a word problem like this on the homework, where you could simplify this as, you could write it as 2r. And now what that does is kind of takes your diameter and changes it into a secant segment, where TU is still going to be our, TU is still our tangent. It touches one point of the circle and goes off. VU is still our secant segment. And then UW is our full secant. So the setup of this would look like we would take 3 squared, set that equal to our secant segment 1 times the length of our full segment, which would be 1 plus, you could write it as R plus R, but we simplified it to plus 2R. So then it would be the same kind of process. You would distribute, boom and boom, and then go through and solve for R. I think you would get out R is equal to 4. Because you have 9, you'd subtract over 1, so you get 8, then split in half, so R is 4.